All right, welcome back. This is our section 4.5 video. We're going to talk about graphing quadratic functions. So let's dive right in. Our objectives are, do we recognize characteristics of parabolas? Can we find the intercepts, both x and y, for the parabola? Can we find a parabola's vertex? Can we graph quadratic functions, which are just parabolas? And can we solve problems where we have to maximize or minimize a quadratic function's values? Okay, so here we go. Graphs of quadratic functions. We have a function, f of x equals ax squared plus bx plus c. Remember, this is a quadratic if a is not 0. And the graph of that is called a parabola. And we're going to look at, in our next slide, what a graph of a quadratic looks like. So let's look at the parts. The vertex is the turning point. So here I have a vertex right there. It's a minimum point. All right. If the parabola opens upward, we have a minimum point. If the parabola opens downward, we have a maximum point. The axis of symmetry is a line that goes vertically through the vertex, and it splits the parabola into two pieces that if I were to fold this half across the line, if I would fold it right on that line, the pieces would match. It's our axis of symmetry. And both of these have an axis of symmetry. It goes vertically through the vertex. Now notice this one is when a is positive. Greater than 0 means positive. So if a is positive, our parabola opens upward. If a is negative, our parabola opens downward. So positive is up, negative is down. And it depends on that leading coefficient, that a value. All right. Next thing we're going to look at is plotting points to graph a parabola. So when we are graphing a parabola, an example one is going to be in 2 slides here. So suppose we have this quadratic function, f of x equals x squared plus 4x plus 3, and we want to graph the parabola. So the first thing we're going to do is we're going to decide whether it opens up or down. Well, this one, since a is positive 1, right, there's a 1 in front of that x squared, it's going to open upward. To determine if the parabola opens up or down, identify a. Well, we've already done that. A is 1. Since a is positive, it's going to open up, right? So right here, to determine if the parabola is up or down, identify the a. So a is 1, which is greater than 0. The parabola is going to open upward, right? Greater than 0, it opens upward. It's just a matter of looking at the a value. Positive is up, negative is down. This one is positive 1, so it opens upward. We're going to continue with this same quadratic. So we know that it opens upward. We're going to make a table of values and plot the points and draw the graph of the parabola. So what do we mean by a table of values? We're going to pick some x values, and typically we're going to pick a couple of negatives. We're going to pick 0 and a couple of positives. And if that's not enough, we'll put in some more. But I'm going to start with these. So remember, y is just f of x. So to find the y value that goes with x equals negative 2, I just go up to my equation and I replace the x with negative 2. We'll just use the function notation here for a second on this first one. So I'm going to do f of negative 2. That's the y value. So I'm going to take negative 2 squared plus 4 times negative 2 plus 3. And I'm going to work that out, and I'm going to find out that my y value is, I can grab a calculator. Just make sure if you use the calculator to put parentheses around the negative 2, and make sure you're multiplying 4 times negative 2. So I get negative 1 when I work that out. I can do the same thing with negative 1. Replace the x with negative 1, so negative 1 squared plus 4 times negative 1 plus 3. And when I work that out, I get 0. I found an X-Intercept. If I plug in 0, I'm going to make sure I use the parentheses. I want you to get in the habit of using those parentheses. I'm squaring the 0. And we get 0 plus 0 plus 3, which is 3. I'm going to let you work on the 1. You plug in the 1. We get 8. I'm not going to go to the 2 because that's just going to go higher. Let me plot these points to show you what we're looking at. We have -2, -1. We have -1, 0. We have 0, 3. Notice I have an X-intercept right here at -1. So that's my X-intercept. This is my Y-intercept. And I have 1, 8. 5, 6, 7, 8. There's 8. Okay, so I'm not exactly sure where it's going from here, but I suspect that -2, -1 might be the vertex. But I'm going to stop going to the right, and I'm going to move over to -3. Over here at -3, what happens? So I plug in -3, and I get 0. There's my other X-intercept. Okay. Get another X-intercept over here. So my vertex must be the point -2, -1. Let me change colors here for a second. I'm just going to put a dashed line vertically through that vertex. Remember that symmetry line. So I'm going to use that symmetry line to help me out. Okay, I switch back to my blue. Expand the screen again. Okay, so use the symmetry line. So notice I have a point 0, 3. It's 2 units away from the axis of symmetry. If I go 1, 2, 1, 2, there has to be a partner on the other side because of the symmetry. The point 1, 8. 1, 2, 3, 1, 2, 3. There has to be a point on the other side. Use that symmetry line to help out. And then we're going to sketch the graph of the parabola going up through those points. Okay, I'm going to try to make that a little nicer. Go through here. Keeps going forever. And over here. Keeps going forever. There's our parabola. Okay, so you can use a table of values and use the symmetry line to help you out. Okay, we're also going to show you how to find the x-intercepts algebraically. So if I just needed to find the x-intercepts, and on the assignment you are just going to have some problems where you find just the x-intercepts without doing a graph, or just the y-intercept without doing a graph. So remember, x-intercepts happen when the y value is 0. Okay, x-intercepts happen when the y value is 0. So if I want to know when the y value is 0, remember f of x is just a fancy way of writing y. F of x is y. To find the y-intercepts, I need to solve and find out when my quadratic is equal to 0, right? Replace the y with the 0. So x squared plus 4x plus 3 equals 0. It's going to get me my x-intercept. So I'm going to factor that. So I'm going to look at my quadratic. A is 1, B is 4, C is 3. So A times C is 3. Remember, we look for two numbers that multiply to create 3 and add up to the B value, which is 4. 1 and 3 are going to work. And remember, at least in my class, we talked about a little shortcut. When A is 1, if A is 1, and only when A is 1, we can factor this as soon as we have our two numbers, 1 and 3, it'll factor as x plus 1 times x plus 3. Now use your zero product property. If x plus 1 equals 0, we'll have a product of 0. If x plus 3 equals 0, we'll have a product of 0. So our only two solutions are going to be x equals -1 and x equals -3. So our x-intercepts are going to be -1 and -3. All right. To find the y-intercept for that quadratic function, we replace the x with 0. You only get to be on the y-axis if the x value is 0. Think about that. When do x when do y-intercepts happen? Talk about y-intercepts right now, right? So if the y-intercept was here, let's say it was right there, that's only going to happen if x is 0, right? That's the point 0, 3. My x value has to be 0 to be on the y-axis. So to find a y-intercept, we just replace the x with 0 in the function. So if I replace the x with 0, those are going to 0 out, and it really just ends up being the c value, right? So if your quadratic is in standard form, the y-intercept is just going to be the c. So our y-intercept is 3. And I think I'll write it that way. Y-intercept is 3. Y-intercept is 3. Okay. Now remember, you might have to write it as a point. So depending on what computer software or computer program you're on, maybe they want it written as a point. Okay. MathXL seems to be asking for it as just a y value, but possibly on other software they might want it as a point, an ordered pair, x and y. Okay. Next up, the vertex of a parabola. How do we find the vertex? That is a key point for the parabola. So if the quadratic, or if the function is written in its standard form, where a is not 0, so we've got this quadratic, the x-coordinate of the vertex has to be at negative b over 2a. Let me show you how I usually do this. I usually write it as negative b over 2a like that. Makes my calculations a little easier usually. I don't make mistakes with the negative signs. So negative b over 2a. The y-coordinate of the vertex, we can then find it by substituting negative b over 2a back into the function. So whatever value we get for negative b over 2a, we plug that back in, and that gives us the y-coordinate of the vertex. So let's practice that. So let's say we have this quadratic, f of x equals x squared plus 4x plus 3, and we wanted to find the vertex using this idea. So we do negative b over 2a. That's going to get me the x-coordinate of the vertex. Notice what my a is. A is 1, b is 4, c is 3. I don't need the c value to find the vertex. I just need the a and the b. So let's plug them in. We do the negative of b, so the opposite of 4, which is negative 4, and we divide by 2 times a. Don't forget the a. If a is not 1, this is going to make a big difference. So I have negative 4 divided by 2, which is negative 2. Then I go and I find the y value by plugging negative 2 into my quadratic. So plug negative 2 into your quadratic. Remember the parentheses. You're squaring the negative 2. And when we do that calculation, we get negative 1. So our vertex is the point negative 2, negative 1. Okay, which matches up with what we found when we were making our table of values earlier. Okay, let's do a couple more examples. We're going to graph a quadratic function, f of x equals x squared minus 2x minus 3. So the first thing we're going to do, so here's some steps you can follow. Now keep in mind that when you get to the MathXL assignment, it really, when you use the quadratic graphing tool, you really only need the vertex and one other point. Yep, a vertex and one other point, and then you've got your graph. Unless it tells you otherwise, unless it tells you to plot more points. Okay, so the parabola opens upward because a is positive 1, right? I'm going to just identify the a, the b, and the c over here. A is 1, b is negative 2, c is negative 3. A is 1, so it opens upward. Upward. Okay. A is positive, so it opens upwards. Find the vertex. So we're going to use x equals negative b over 2a. We're going to plug in negative 2 for the b, so we do the opposite of negative 2, which becomes positive 2. So we get 2 over 2, which is 1. And then we go back to the equation for the function. We replace the x with 1. And we find out that y is -4. 1 take away 2 take away 3 is -4. So our vertex is the point 1, -4. I'm going to go ahead and put that on my graph. 1, -4 is right there. Okay, now I'm going to find the x-intercept. So I'm going to remember that x-intercepts happen when y equals 0. Here's my formula that calculates y. I need to know when that is 0, which x values give me an output of 0. Here's my formula for calculating output. Okay, so I'm going to look at that. A times c is -3. Remember to look for two numbers that have a product of -3 and a sum of -2, and then I'll just go right to the factorization since a is 1. Okay, let's see, +1, -3 will do. So we have x plus 1, there's my +1, x minus 3, and then if I set each factor equal to 0, this one's going to get me x equals -1. This one's going to get me x equals 3. Okay, so my intercepts are at -1 and +3. Notice that fits with my symmetry line. My symmetry line is through the vertex, vertically through the vertex. So I have to have a point on each side of that axis of symmetry, right? Let me change colors really quick. Draw that symmetry line so you can visualize it. There's my symmetry line right through the vertex. My x-intercepts have to be mirror images or reflections across that line. Okay, they are 2 units away on each side. All right, so we've got the x-intercepts. Now we're going to find the y-intercept. The y-intercept is going to happen by plugging in x equals 0. Sorry. So if I replace the x with 0, I get y equals, well, look at it, 0 and 0, and then subtract 3. We get -3. So we've got right there. That would give me a partner over here, and then we'll draw the sketch. If you needed more points, you could look and see what happens when x is 4. 16 take away 8. Oh, it's going to go through 5, I think. But if you don't plot any other points and you just sketch it from there, I think we'd be okay. But if you needed more points, you could plug in x equals 4 and then use the symmetry to find a partner over here when x is -2. Oops, struggling a little bit. You won't have that problem ethics, so we'll draw it for you. Okay, there's my quadratic. Still looks a little sloppy. A little bit sloppy. Okay. All right, we're going to do another example. And this one, for some reason, it has been split into 2 slides. I'm not exactly sure why. But we're going to graph this quadratic. So step 1 and step 2 are on this slide, and then step 3 and step 4 are on the other slide. So we're going to determine whether the parabola opens up or down. This one's going to open down because a is -1. Look at your a value is -1. Your b value is 4. Your c value is -1. It's going to open downward because a is negative. So it's opening downward. We're going to find the vertex. So we're going to use x equals -b over 2a. So we're going to do the opposite, or the negative of 4. There's my b. 2 times -1. Don't forget the a, right? It's not going to come out right if we don't. Negative divided by negative is, oh, that's +2. Okay. Then I find my y value by plugging in 2 for x. Now, be careful. On this one, I'm not going to put parentheses around the -2 because this negative, back at your function, this negative is -1 times x squared. I'm squaring the 2, not the -2. I'm squaring a 2, and then I'm multiplying it by a -1. So be super careful with that. 4 times 2, and then -1. I do that calculation. I come up with y equals 3. So my vertex is the point 2, 3. So we're here at 2, 3 for our vertex, and we're going to open down from there. Now I'm going to flip back and forth between these two screens because I need to find intercepts, and then I'm going to finish the graph. So over here, we're going to find the X-intercepts and then find the Y-intercepts. My mouse is being a little glitchy. So for the X-intercepts, remember we want to know when y equals 0. Here's my y. So in other words, we solve the quadratic equation, negative x squared plus 4x minus 1 equals 0. Now, I don't like to have a negative leading coefficient when I'm factoring or when I'm using the quadratic formula either. So I'm going to always multiply both sides of that equation by negative 1. Okay? So I'm going to multiply both sides of that equation by negative 1 and get x squared. Remember to distribute. Minus 4x plus 1. 0 times negative 1 is still 0. So I have a leading coefficient that's positive, and it makes it so much easier for me if I have that. So I'm going to plug numbers into the quadratic formula. So I have an a value of 1, a b value of negative 4, and a c value of 1. So for this equation, right, for that equation, x equals negative b, x equals negative b plus or minus the square root. Okay, here we go. Little memorization technique. The negative of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so we have that. Now we're going to simplify that. So x equals, opposite of negative 4 is positive 4, plus or minus the square root of. Calculate that number under the radical. 16 take away 4 is 12, and then over 2. Now, if you want to do decimals, now would be if you need decimals, now would be a great time to get those. But if you need exact values, you simplify the square root. If you just need decimals, grab your calculator right now and do 4 plus the square root of 12 divide by 2, right? And you can do that on your calculator. And then you can do the same thing with the subtraction sign, right? But if you need exact answers, and I'm going to assume we want exact answers, I'm going to go ahead and simplify this. Square root of 12 is, let's see, 12 is 4 times 3. The 2 comes out, so we have 2 radical 3. And then remember, we reduce it by taking a 2 out of the 4 and out of the 2 radical 3. Don't touch the 3. So my intercepts, 2 plus the square root of 3 and 2 minus the square root of 3. So like I said, if I need decimal approximations, I can either do them from right here, or I can do them after I've simplified. 2 plus the square root of 3. I'm going to grab my calculator and do that. 2 plus the square root of 3 is 3.73. And that's almost 3 3/4. And then 2 minus the square root of 3 is about, it rounds to the nearest hundredth, it's 0.27. So about 1/4. Okay. And then our y-intercept, let's go ahead and find that. Our y-intercept is going to be, if I plug in x equals 0, I get y equals negative 1. Remember, it's just that c value. So I'm going to go back to my graph, and I'm going to put that on it. Okay? So y equals negative 1 is my y-intercept. Good, it's below my vertex. It better be. Notice using the symmetry, I can go 2 units on the other side of the vertex and find another point. And then my intercepts, okay, look back at them. They were about 1/4 and 3 3/4. Close, right? So if that's enough points, then you go ahead and draw it from there. And if you need more, you can plug in, let's say, x equals 1, x equals 3, You can plug in x equals -1. You could plug in x equals negative or +5, right? You could find some y values for other x values. That looks a little sharp. Okay, and there is our graph. And that is the end of our 4.5 notes.